Okay, so let's start today's session. So we are discussing on the SLT drawing preparations, and so far we have discussed SLT for the AIS type substation, right? The SLT for the AIS type substation that we completed last week. So any query regarding that? And model number 4, any query regarding the AIS SLT? Yeah, thanks, Rajkumar. Okay, so if there is no query, so we start the next model, which is model number 5, that is SLT for the gas insulated switchgear substations for the GIS type substation. So this is the agenda that we will discuss, but this is a brief agenda. Let us discuss in the detail about the GIS type substations. So I request to all of you, please give your full dedication about the topic, because a lot of things we are going to discuss together. So I need the listen from all of you. So this GIS SLT discussions we are dividing. This GIS substations discussions we are dividing into three parts. So first we'll discuss about the GIS introduction and the GIS constructions. Thereafter we will discuss about the GIS SLT, and then we will discuss about the GIS layout. Just give me 1 second. Uh, Others who have the background noise, please mute yourself. Majhar, mute yourself. Yeah. So these discussions we have divided into three parts. So let us start first with the introduction, our constructions, and then taking the construction concept, we will enter into the SLD preparations, and taking the constructions plus SLD concept, we will enter into the layout drawing preparation for the GIS. So let us start first with the GIS constructions and the introduction first. And like we have listed few main topic, the high level point, like why the GIS type subsystem is required, the history or background about the GIS, what is GIS introductions, what is GIS subsystems, type of enclosure, compartment or partition of the GIS, the gas leakage rate, the phase segregations, model fittings, and then advantage, disadvantage of the GIS, sequence of equipment in the GIS, the external termination of the GIS type test, SLD, difference in AIS and GIS SLD, layout, ratings, and special tools and tactics required for the GIS substations installation. So these are few high level point. So let us start first, like type of the substations that we can create or that we can construct, or why the GIS type subsystem is required. So the substations can be constructed as an outdoor type, which is called as an air insulated switchgear substations. For an example, we can see this layout. This is one example for the air insulated switchgear substations. Or we can see another example. This is also an example for the air insulated switchgear substations. So if you see between in these substations, which is a solar power plant substations, between the equipment, the air working as an insulating medium, right? So we call this type of the substation as a air insulating switchgear substations, or AIS substations in the short. So this is one way doing the constructions or doing the installations of the substations, or this is one way of the substation project. The another way, it could be a and this that would be obviously outdoor type subsystems, because air we are using as an insulating medium, so we have to install as an outdoor substations. Second way, we can make a substations indoor type inside the building, or a hybrid type. Hybrid type is combination of outdoor plus indoor, which is are AIS or GIS. Hybrid type as a combination of AIS and GIS substations. Further, the indoor type substations which we are installing inside the building, it we can divide into two types based on the voltage level of the electrical system. If our electrical voltage between the range of 415 voltage till 33 kilovoltage means from LT to HT in that voltage. In that case, for the electrical installations, we take metal enclosed switchgear type electrical installations. Like you can see here, this is one example of this is a metal enclosed switchgear, switchboard. This is also a kind of the indoor substations, but voltage between 415 voltage to 33 kilovoltage. And once the voltage level increase from 33 kilovoltage to higher level, in that case, we can make this indoor substations as a GIS type substations. So substation site located in urban area where space is very costly and limited are the substation site located in very populated areas or in mountain areas where space is limited. The AIS type substation is not sometimes the good choice or best choice. For those type of the sites, the GIS type substations will be more suitable than the AIS type substations. The GIS takes only 10 to 15% of the space compared to the same rating, same scope, same number of the bay of AIS type substations. I hope I'm clear with this. So what we discussed, let us, so we'll go with these presentations. Along with that, the major point also will note down. So here we discussed that in substations we can like construct into three part. It could be a conventional AIS substations. It could be a indoor GIS substations. Sorry, let me like AIS or outdoor we can write it. Outdoor we can write it, and then indoor, indoor type, indoor type, and this indoor type further we divide into two type of the electrical installations. If the voltage rating is up to 33 kilovoltage HT voltage, then we can go with the switchboard, right? And once the voltage rating is increased, the number of equipment quantity increase, the electrical clearances requirement is increased, right? The fault level increase, the voltage level increase, the voltage pressure increase, the insulation requirement increased. So in that case of the voltage means above 33 kilovoltage, we can make the substance as the GIS type. Third, we can make the substance as hybrid type. This hybrid type is combination of AIS plus GIS. Means few equipment we can take as air insulated switchgear and few equipments we can take inside a gas insulated switchgear. Like for example, we can take the circuit breaker and disconnectors or isolators in one hybrid switchgear as a hybrid switchgear. So we are putting the breaker and disconnectors in one common enclosures. So this kind of subsystems, it form as a hybrid subsystems. So here here space requirement is less compared to AIS, and here when few like this space requirement is between the AIS and the GIS, between that range it is coming. I hope I'm clear with this. The type of the subsystems, the type of the electrical installations, uh, right? So AIS we have discussed so far. That SLD we have discussed so far. So AIS we have discussed so far in the model number 4. The switchboard also we have discussed in the model number 4. So now we are coming about the GIS substations. And this hybrid would be the combination of AIS plus GIS. Right? So This we will discuss now in under the module number 5. So let us start with the GIS history. Let us start with the GIS history, that how this GIS developed, how this GIS developed. So GIS technology was originally developed in Japan in the 1960s due to the critical need to develop substations with a reduced site area, with a greatly reduced site area. After that, GIS technology was slowly adopted by various other countries over the years. After about 5 years of the evaluations and testing of the GIS substations, whereas for the countries where enough site space is available, their still preference is the conventional AIS type substations due to the higher cost of GIS than AIS, and due to the higher outage time of the GIS compared to the AIS. So they prefer the AIS substations, but where the space is not available or is very limited, is very less available, in those area we go with the compact GIS type substations. I hope I'm clear with this. So here we have taken some comparison, like this is if we need to make one bay, and if that bay we are making outdoor, so this much area, this much length required, this much site required. But the same bay, if we are making with taking the GIS, in that case, this all equipment we could enclose in metal enclosures, and we can install in very reduced area, right? So the GIS, like the correct name of the GIS is gas insulated switchgear. Why I'm telling this name? Because most of the time are in many specifications, this GIS is written as gas insulated substations. So in order to correct this concept, I'm telling what is the correct name of the GIS. So the GIS is stand for the gas insulated switchgear. Means the switchgear, the equipment is insulated by the SF6 gas. So due to that reason, the correct name of the GIS is gas insulated switchgear, not the gas insulated substations, as it sometimes referred in some specifications. So stand for the GIS stand for the gas insulated switchgear, not the substation. This is what I'm trying to stress here. Now, the gas insulated switchgear, GIS substations, are compact assembly of equipment which is enclosed in metal housing, and that metal housing filled with sulfur hexafluoride gas at SF6 gas in short, between each piece of equipment and between different phases of the bay. GIS contains the same equipment as in AIS substations, but the difference is that all the live parts and all the equipment enclosed in metal housing and filled with the SF6 gas. And in AIS, equipment is placed outdoor and air work as an insulating medium. That already we have seen, that equipment placed outdoor, and between the equipment, air is the insulating medium, right? Air is work as an insulating medium. The GIS metal housing or GIS metal enclosure that you can see here. Now we are putting the equipment inside a metal housing. So this metal housing is not a one common metal housing. This metal housing or the GIS enclosures are internally divided into several small gas section modules or compartment by using the gas tight insulating barriers. The location of gas barrier insulators must be clearly visible outside the enclosure by a band of different color, and this is used for the safety purpose. So if you see I have taken a GIS site photo. So in that, if you see this orange color band, could you see here this orange color band?
Yes.
So these orange color band is representing the gas barrier insulators. Let us see a few more example about the assembly of the equipment, compact assembly of the equipment in case of the gas GIS substations. So this is a few example of the compact assembly of equipment in GIS. So if you see, this is the breaker equipment. So how the breaker is assembled? This is the breaker assembly. So here we have a breaker enclosure. In that we have the fixed and moving contact, and then we have operating mechanism for the breaker as well, right? And then this assembly for the disconnectors and earthing switch. This disconnectors and for the earthing switch as well. This is again for the earthing switch, but that earthing switch would be high speed operated or spring operated earthing switch. I'll come on that what I mean by the high speed earthing switch and why we require this earthing switch in the GIS type substation. This assembly for the bus bar earthing switch. So if you see this, the top compartment, this compartment, this compartment, this compartment, they are representing the earthing switch. This compartment here, these are representing the disconnectors. I have taken a clear drawing in that. Again, I have marked up all the compact assembly of equipment. This is for the bus bar earthing switch here. This is bus bar disconnectors. So if we need to indicate the bus bar disconnectors, so this is the compact assembly for that. So if you see here, could you see this one? The extended portion here. Could you
Yes,
see?
sir.
So this is representing the disconnector. Why I'm telling this because the engineers who are not familiar with the GIS type substations, and when they do a visit of the GIS substations, so they face difficulty to identify the equipment. Am I clear? Means I'm telling it is my GIS, but how you will identify that which enclosure or which module for which equipment? So in order to do identifications, I'm taking each equipment separately. I will take with help of the drawing as well. This is a bus bar disconnector. So this extended portion is in representing the disconnectors, right? And then this model for the CT. This is the bushings connections. Here we have the some bus bar connectors. Here we have bus bar, the bus bar which is coming like this, right? Means the bus bar, as you can see here, the bus bar that you can see here, this bus bars, this bus bars. So this is now changing like that, the bus bar. VT is representing like this, surge arrestor like this, and we required some angles, 90-degree angle, 45-degree angle of the enclosures. So this is the like representation of the angles of the bus duct enclosures. This is again long bus, small. This is the short bus. This is sliding bus, billows, 45-degree angle bus. This is cable chamber. When we have cross busing, so this kind of the model we use for the cross busings. So this is the example that I'm telling that GIS is the compact assembly of equipment and placed in a metallic housing. Am I clear with this sentence? The GIS are compact assembly of equipment enclosed in metal housing filled with gas. So you can see here, this is the compact assembly of all equipment that we are using. And in that assembly, we are filling the gas as well, the subsys gas as well. Let us do a comparison between AIS and GIS, how they looks like, how they appears. So I have taken a side photo of the AIS and then comparing with the GIS. So if you see, this is our conventional AIS type substation. So here we have the bus bar. From the bus bar, we are taking the drop, and the disconnectors are isolators. So you can see here we have the isolators, three-phase isolators, and then isolator connecting to the breaker, and then breaker is further connecting to the CT, and then again line disconnectors, and then tariff CT, and then again surge arresters, and then CVT, and then surge arresters, and then the outgoing transmission line going with help of the tower, dead end country and dead end tower here. So to make a bay, a line bay, or in case of air insulated switchgear substations or in AI substations, we require this much length and this much width just for the one bay from here to here. So equipment placed outdoor and air work as an insulating medium. So higher footprint area is required in AIS. Same equipment now, if we are using the GIS, then same equipment now convert to this assembly. So here, if you see the bus bar, that if you can see here, it is not coming full, but the few portion of the bus bar you can see here. So this bus bar, now it is installed like this. So if you see this 1, 2, 3, this is indicating or representing the bus bar 1. Here it is representing the bus bar 2. And this portion, could you see this portion, extended one, extended here, and here again extended. And here we have the operating mechanisms. So this assembly representing the bus disconnectors, bus isolators. As you can see here, this is my bus isolator in case of the AIS type substations. And here we have two bus bar scheme in this particular GIS photo. So bus 1 here, bus 2 here, and due to that reason we have two bus disconnectors, one here and one here. And then we have, after the disconnectors, we have the circuit breaker module, breaker equipment here. So now you see all equipment now converting into module. So now breaker equipment here, and now this is the breaker, this one. This one is the breaker module. This is horizontal arrangement of the module. It could be horizontal or it could be vertical as well. But here in this photo, it is horizontal movement of the horizontal placement of the module. And after that, we have CT. So CT equipment, now CT equipment converting or changing into CT module. So this assembly is representing the CT modules. And then we have again disconnector, line disconnector. So here we have the line disconnectors. And this position somewhere, if we are using the line disconnector, so it will come here. So earthing switch model coming here. So earthing switch, and if in case we are using the disconnector here, so that model also will come here. And then here we have the one additional earth switch that we take in GIS, which is fast acting earthing switch. So that coming here on the top. And then we have VT over here, VT equipment over here. This VT now equipment coming over here. And then if in case we are taking cable, so in that case, the cable uh, exit our cable chamber coming here. If we are using the transmission line, in that case, from here we have to take the bus duct, and that bus duct will cross the GIS building or hall, and then it will go and terminate to the gas to air bushings, and from gas to air bushings we will take the conductor for the overhead transmission line. So am I clear with the comparison between AIS and GIS? This is what we discussed. We discussed that in GIS, GIS is compact assembly of the equipment. So I hope I'm clear about this as well. This two sentence, right? And as I told that in the GIS and AIS have the same equipment, so having the same equipment, but the equipment installation medium is changing now. So equipment includes metal housing filled with SF6 gas and lower footprint area required into the GIS. So here we can see one more example, like here we have the enclosures, the enclosure, inside the enclosures we are like placing the equipment, and we are filling the aseptic gas in the enclosure. So substations equipment enclosed in a metal housing and filled with the aseptic gas in case we have the GIS type substations. I hope I am clear with this. So let us discuss that where the GIS type substation is preferred or is required, or where we prefer this for the AIS type substations. So what we discussed so far, what is mean by the GIS, correct? What is GIS? That we discussed. What is
Yes.
GIS? What is the meaning of GIS? What is the GIS? Right? We discussed it. And then we discussed a brief comparison of the AIS plus a brief comparison between AIS and AIS. One second. Chetan, Kalam, please mute yourself. Chetan. The participant who from the background noise have please they mute themselves. Otherwise, like I'm telling 1, 2, 3 times after that, like I have to mute all, and then if in case you have any query, you cannot unmute them. Okay, so what we discuss, what is GIS? Difference between AIS and GIS that we discuss, right? Let us discuss now where we prefer this GIS type subsystems, prefer GIS over the AIS type subsystems. So I think you have the clear idea that where we prefer the GIS. So in the GIS we are using the SF6 gas. The dielectric or insulating strength of SF6 gas is very much higher than air. Therefore, the electrical clearance distance required between different phases and between each piece of equipment in GIS is much less than AIS. Majhar and others as well, whatever the query you have, you note down on a separate pen and paper, and then in the last we will discuss one by one. So do not ping between the class. Do not interrupt the flow. Okay, Majhar? Yeah. So I'm telling that the insulating strength of the gas is very much higher than the air. Therefore, the electrical clearance distance required between different phases and between each piece of equipment in GIS is much lesser than AIS. This reduced electrical clearance reduces the overall spacing of each piece of equipment, and thus it is reducing the overall complete substation overall size, which is about 10 to 10 percentage required comparison to any conventional AIS type substations. So therefore, the GIS is preferred where the site space is limited or less available. Since the equipment is placed in metal enclosed housing in GIS, therefore a GIS substations can be installed inside the building, and thus it is called as indoor type substations. Or few times we can install GIS in the basement as well, in underground basement as well. So here, this is one example that this GIS type substations installed inside the building, and we are calling as the indoor type substations. So where it is preferred, where the space is limited, at those locations, it is preferred to use the GIS type substations. So where the GIS substation is preferred, the same things let us discuss with other point as well. So below a few example of the GIS substation preference. Where space is much less, GIS is preferred because of GIS takes only 10% of space compared to AIS. GIS is compact design that reduce space requirements. So where the site land are very costly, then GIS is preferred over the AIS. Where high pollution and corrosion in the outdoor environment from industrial plants and from desert climates, then GIS is preferred because the installation is indoor type inside the building. So high pollutions, corrosion from industrial plants and desert climate do not affect the GIS. So at those locations, we also prefer the GIS type substations. But the underground substation required in that project, we take the GIS type substations. Extension of existing conventional outdoor installations and limited ground area, unlimited space available. In that kind of the project, we take GIS type substations. In hilly area where space is very much limited, in that kind of the area also we prefer to use the GIS type substations. Let us see few advantages and disadvantages of the GIS as well. So GIS subsystems are preferred because of the following reasons: compact design, reduced space requirement, high reliability, locations advantage, especially in area like in town area or urban area where space is very much costly. In that it is advantage. An environmental advantage as rain, dust, snow, ice, salt do not affect the GIS. High pollutions and corrosion from industrial plants are by marine and desert climate do not affect the GIS. So this is also advantage of the GIS. And in the project where we require the underground services, in that case also the GIS is preferred. This is the advantage of the GIS. Along with the advantage, the GIS also have few disadvantage. So let us see about the disadvantage as well. So the first disadvantage that it is costly compared to the AIS. So high cost compared to the conventional outdoor substations. Till 132 kV and above rating, the cost is almost near about 1.5 times per bay higher compared to AIS. This is one disadvantage. Second disadvantage, excessive damage in case of internal fault and long outage periods. So if in case any internal fault happened, in that case, the outage time, maintenance time is higher in the GIS compared to the AIS. So this is a also it is a major disadvantage of the GIS. And third, which is a very dangerous or very major disadvantage of the GIS is VFTO. VFTO stands for the very fast transient over voltage. This transient over voltage comes on on GIS, which is also very disadvantage for the GIS substations. There are generally indoor and need separate buildings, so building cost also added in the GIS. Procurement and supply of gas to the site are problematic, and adequate stock of gas must be maintained at all the time in the GIS substations. Under the influence of an arc and the presence of moisture, SF6 is distress and secondary decomposition product such as highly corrosive hydrogen fluoride, highly toxic gases start to create. So these weaken the insulation property of the SF6 gas and may cause rapid corrosion in high voltage switchgear. So this is also a kind of the disadvantage. So in the GIS, we also use the moisture absorbent so that there should not be any presence of moisture in the SF6 module. These days, every GIS component gas compartment is fitted with the gas density monitor, which has two settings: low gas pressure alarm for online gas topping and tripping of circuit breaker. Means this is also we required the monitoring we required for the module. So this is again a cost added. Floor underneath the GIS is built from reinforced concrete. The structural steel is used in the earthing system. So cost is also a concern in case of the GIS type substations. So let us see a bit more about the VFTO disadvantage of the GIS and how it occurs. So during the switching action of the disconnectors in GIS, many pre-strike and re-strike occurs between the breaker, between the bus bar and the GIS, between these two, because the reason the space between the disconnector and the bus bar is very limited. If you see here, if you see the same AIS, so if you see between the bus bar and the disconnector, here space is very much larger. But at the same time, if we refer to the GIS, between the bus bar and the moving contact of the disconnector, space is very less. So due to this less space between the live bus bar and moving contact of the disconnectors, VFTU start occurring. During the switching action of the disconnector in GIS, many pre-strike and re-strike occurs. So the disconnectors operate at low speed, hence the operation of disconnector is the leading cause of the generating VFTO. These transient voltage are short durations and very high frequency. The rise time is in the range of nanoseconds with frequency of megahertz. This is a kind of high frequency signal, high frequency wave form generating on the GIS substations. The formation of VFTU and dispersion of the VFTU throughout the GIS can produce internal and external transient over voltage. The internal VFTU cause high stress on the insulation system, while external VFTU are dangerous for the nearby connected equipment. So this is a like major disadvantage of the VFTU. I hope I'm clear with the disadvantage and VFTU and why the VFTU is generated. Am I clear so far? Am I clear
So
with?
what is external VFQ?
Yeah, so we discussed that what is GIS, what is GIS. We discussed where we prefer to use the GIS, and then we discuss. So let us see. This is point number one. We discussed this point number two. We discussed, and then we discuss the advantage of the GIS, and then we discuss about the disadvantage about the disadvantage about the GIS, right? And to be honest, if we want to add the two major disadvantages, so when we can say that this is the higher cost, higher cost. This is one disadvantage. Are three major three and higher higher outage time, higher outage time, higher outage time if any fault occur inside the GIS. And third is the VFTU. This voltage generations could be a disadvantage.
Hello, sir. I have one doubt. You have mentioned external VFQ. What is mean by the
Sir,
external VFQ? Can you tell
Uh,
that?
external VFTU coming on the outer enclosure of the GIS.
Internal VFQ is due to the switching action of isolator, but
Yeah.
external VFQ occur due to which?
Let us do one thing, Vishal. Give me just 2 hours to me first. Let me finish. And then in the last week, 30 minutes we have, and then we can discuss all the query and answers. Q&A.
Okay, sir. Okay.
Do not divert the discussions into the Q&A tab. Okay. Note down, you said with the pen and papers and note down the queries. We can discuss one to one. Okay. Yeah. Now let us discuss about the equipment that we use in the GIS and sequence of equipment in the GIS. Sequence of equipment in the GIS. So basically, the GIS contains the same equipment as in AIS service stations, but the difference is that the GIS, all live parts, all equipment, all phases are enclosed in metal housing and filled with SF6 gas. So here we can see that all equipment like the bus bar, disconnectors, circuit breaker, CT, then again line disconnectors, cable sealing in, high voltage transformer, high speed earthing switch, all equipment is metal housing and filled with the SF6 gas. The gas in each compartment, we take the gas monitoring devices is added, and high speed earthing switches and termination equipment are additional equipment in case of GIS type substations. Means in the GIS have the same equipment, but in the GIS we are taking three additional equipment. One is the in each module it should have the gas monitoring facility or gas monitoring device. This is one. Second, GIS have the high speed earthing switch, and third one additional interface equipment required to connect the GIS to the AIS, which is called as termination equipment. So this is third equipment required. So these three additional equipment required when we take the GIS type subsystems. And metal enclosed housing is placed inside the GIS buildings. Right. Let us see some example with help of the SLD. So when we make the SLD in case of the AIS or GIS, SLD would be the similar. SLD would be the similar like the bus bar disconnectors, earthing switch CT, breaker CT, and then again line disconnectors, earthing switch, and then terminations. But SLD would be the almost similar. Few additional equipment required, as we discussed here. So that those equipment like high speed earthing switch and the termination equipment we have to indicate into the GIS SLD, and those equipment that we will install inside the GIS modules are enclosures. So up to how this enclosure we decided, or what is the concept for that. So up to 145 kV or up to 132 kV. If you see here, there is two separate example of the GIS enclosures. One enclosure here and second enclosure is here. So up to 145 kV or up to 132 kV, the complete GIS module is factory assembled by the GIS manufacturer or by the GIS supplier. And this complete assembly include all equipment such as breaker, isolator, earthing switch, CTVT, control protections equipment requirement, and interlocking and monitoring facility have all equipment. So when we go for the up to 132 kV, we take a factory assembled GIS module and including all equipment. So just make noted here, noted here. We discuss about the sequence of equipment, right? Equipment, sequence of equipment connections, sequence of equipment connection in the GIS. So we discussed that the sequence of equipment connection in the GIS would be same as in the AIS, but three additional equipment would be required. We discussed like we have to provide the, since we are using the gas, so we have to provide the gas monitoring, the gas density monitors. Then we have to provide the high-speed earthing switch. I'll come on the high-speed earthing switch, that why it is required. And then we have to provide the terminations equipment to terminate the GIS into the AIS terminations equipment. And then we are discussing how the enclosure module is constructed. So up to 132 kV, up to 132 kV, up to 132 kV means for 66 kilo voltage, 110 kilo voltage, 132 kilo voltage. The GIS module is factory assembled, factory assembled, factory assembled, and all equipment is installed and assembled by the GIS manufacturer. When we go above 132 kV means the next voltage for after 132 kV is 220 kV. So when we go for the 220 kilo voltage and above, in that case, we do the equipment assembly at the site. So here if you see, above 145 kV, GIS is assembled into separate modules. You can see here one example that this is this model for the bus bar and the disconnectors, this model for the breaker, this model for the CT, VT, cable terminations, high speed earthing switch. So all equipment have a separate module which will be assembled or installed at the site with flange connections, nut and bolt connections, and with plug-in contact for the conductors. The GIS manufacturer will supply the gas required for the installation, initial filling to the pressure required for on-site testing and commissioning, and provide the suitable machinery and tools for this activity. So am I clear with this concept? Like we are trying to establish the concept about the GIS. So am I clear here? Up to here we will go with the factory assembled, and here we have to take the separate equipment modules, and that assembly we have to do at the site. assembly at the site we have to perform, right? So here again, the same separate models, assembly to be done at the site above 145 kb. So let us start with the module constructions and what the fittings we take for the module. So each models, their fittings and module constructions as well. So each model, so as we discussed that here factory assembled, each model factory assembles, and up to 20 kilovoltage and above module assembly at the site. So now let us discuss about the module constructions and the module fittings, the fittings that we use for the each individual models. So yes, module constructions and the module fittings. So let us discuss first about the GIS enclosure. Here we have the GIS enclosure, outer enclosure. You can see the outer enclosure of the GIS, right? Outer enclosure of the GIS. So the GIS has metal enclosed equipment. So this is my metal enclosure. Inside that enclosure, we are putting the equipment. So GIS is metal enclosed equipment, and this enclosure is filled with SF6 gas. The GIS enclosure can be made of aluminum alloy, or stainless steel material. Out of three, the most preferred is aluminum alloy. Is usually preferred due to high resistance to corrosion, low electrical losses, and no magnetic losses. So due to that reason, the aluminum alloy type enclosure we prefer. The exterior portion of the GIS enclosure must be painted with suitable anti-corrosive paint. So paint we have to use at the on the outer side of the GIS enclosure. The enclosure shall be sized to carry an induced current equal to the rated current of the bus bar by the GIS manufacturer. Means here we are telling that we are using the GIS enclosure. Inside the GIS enclosure, the bus bar conductor is running, right? So this bus bar conductor will also induce the current on this enclosure, or may induce the current on this enclosure. So enclosure earthing we have to ensure that enclosures we earth, and this enclosure to be designed by the GIS manufacturer, taking the capacity that it can carry the same amount of the current if at any chance the current is coming on this enclosure. And transient voltage whatever the transient voltage developing inside this enclosure, that will induce on the outer side of the enclosure as well, which we are telling as the external VFTU. External VFTU, right? So in order to eliminate, uh, we do the enclosures earthing, and sometimes few company or few client ask for the insulations coordination study as well, in order to ensure that whatever the voltage is inducing on the enclosure should withstand those voltage. And sometimes if it is not voltage coming beyond the limit, sometimes we have to provide the surge arrestor or LA or lightning arrestor inside the GIS enclosure as well, at the GIS enclosure as well. The GIS manufacturer, the GIS manufacturer shall demonstrate that the enclosure can withstand an internal arc of the rated short circuit current. So whatever short circuit current we are taking 40 kiloampere, 50 kiloampere. So whatever the arc will generate uh, from that short circuit current, the GIS supplier have to demonstrate that the enclosure can withstand that much internal arc by conducting a type test on the compartment. So they need to provide the type test report. The conductor and live parts shall be mounted on high-graded epoxy resin insulators inside the enclosure. So here, this is one like piece of example that we have taken. So here we are taking that in here we have the conductors, the bus bar conductors placed inside the enclosure, and this is supported by the high graded epoxy resin insulators. The conductor could be either copper type or aluminum type as per the client requirement or as per the OEM, the GIS manufacturer practice. So they need to design about these conductors. So I hope I'm clear about the GIS enclosures material. So what material we take for the GIS enclosure? What materials we take? The aluminum,
Limonare.
the aluminum alloy type, right? Means I'm telling that I will take the
Yes, sir.
metal enclosed. So in order in instead of telling metal enclosed, I can tell aluminum alloy enclosed, right? Aluminum alloy type enclosures we take, and we discuss that what should be the enclosure capability as well. Enclosures electrical capability also we discuss. So here, this is one example of the enclosures. Here we have the connections for the flange connections arrangement provided here. So further to reduce the injury or fault area, because we have seen that the internal fault is major disadvantage or one of the major disadvantage in the GIS in the service continuity. So due to that reason, to reduce the injury or fault area impact on the GIS enclosure and to get the maintenance flexibility in GIS, the GIS enclosure is subdivided into several small compartment or small partitions or small modules, whatever you can say. With help and these divisions is achieved with help of the gas type barrier. So this gas type barrier you can see in the orange color here. This is one compartment here, one compartment here, one compartment here, one compartment. So this gas type barrier insulator provide the compartmentalization of the GIS enclosure. And this compartmentalization to be done as per the clause number 5.104 of IEC 62271 part 203 or 203, 203, whatever. A gas type barrier helps to subdivide the GIS enclosure suitably into individual arc and gas proof compartment. Am I clear with this? Am I clear with this? So we discussed that we take aluminum alloy type enclosure. This is one line. Second, we discussed that we take this enclosure is not a continuous enclosure. This enclosure is subdivided with help of the gas type insulator. So we take basically two type of the insulators we take in GIS. Two type of insulators we take. One is the support insulator, and one is gas tight barrier insulators or gas type insulator or barrier insulators. So this insulator, so this support insulator allow to pass the gas, and it just support the conductors. It just support the conductors, the bus bar conductors. Whereas the gas type barrier insulators, it not allowed to pass the gas. It will seal the gas. So whatever the gas here, this gas is this enclosure is subdivided with help of the gas type barrier. Am I clear? Am I clear so far about the module constructions, about the enclosures, which material we take and how we divide this? So we divide with help of the gas barrier insulators, and why we divide that? Why we divide that? Am I clear that why we divide this? Why we divide this? Why we divide this? So if suppose we are not dividing here, if any short circuit, if any arc generated, so entire enclosure will be affected by that arc. But if we divide, so if any arc generated, so only this portion would be affected. This portion will not affect, this portion will not affect. So only we have to do the maintenance of this portions only. The other portions is heavy portions. So we are saving the gas quantity as well. Now, again, the GIS enclosure partitions should be designed to permit the isolation of faulty section for maintenance with a minimum outage of the GIS enclosure healthy portions. Or we can say due to the gas type barrier, maintenance on one feeder shall be possible without de-energizing or degassing the adjacent feeders are degassing the other portions of the GIS module. So the SF6 gas requirement was saved at the time of the maintenance. If we are dividing into small small portion of the compartment, the whole GIS. Various other fittings are installed on each compartment to protect and restrict damage in the GIS, such as pressure relief device, the pressure relief valves, diaphragms, bursting disc, or we call as BD bursting disc, which the GIS manufacturers shall provide on each enclosure module. So as we discuss here, that these partitions are save the gas quantity and it allow easy maintenance of the GIS enclosure. So what we do when we do the project from the manufacturer, we ask one service continuity or we ask the manufacturer one MRE procedure. MRE procedure stand for the, so as a design engineer, we need to ask the GIS manufacturer for the MRE procedure, which is maintenance, repair, extension procedure of the GIS, are the service continuity procedure in order to perform the GIS maintenance. So here they will provide the MRE procedures by taking the each and every compartment in separate. So here we have the gas SLD. This is a one half breaker scheme SLD. So bus bar 1, bus bar 2, and then here we have the bay 1. This bay is line coming this side, and then here we have the bay 2, this line coming to the upper side, and here we have the tie bay. This portion is the tie bay. Now, if in case we require this filter or this bay maintenance, in that case how we will do this? So this is a example of the MRE procedures. So here we have the bus bar, main 1, main 2. Here we have main 1, main 2, and so now we need to take the breaker under maintenance. So if you see here this color code, so the blue one, gas compartment at zero pressure, because we are doing the maintenance on the breaker. So we have to degassing of the breaker. So this compartment at zero pressure. Now the adjacent compartment means from breaker, here we have the CT compartment, which is the adjacent compartment, and here this compartment. This is also one of the adjacent compartment. So here we not do complete degassing, but we reduce the gas pressure. So yellow one, gas compartment at reduced pressure, and the red one, this red one, no need to touch this compartment. So gas compartment at rated SF6 gas pressure, this one and this one, right? Am I clear with the MRE procedure for the GIS? And then here the steps to perform this. So first disconnectors on both sides of, now we need to do the breaker maintenance. So on both breaker we have to open, and then on both side of the breaker the disconnectors shall be in open status. Maintenance earthing switch on both side of the breaker shall be in closed status. Degas the SF6 gas compartment of the breaker. Reduce the pressure in adjacent compartment of breaker to atmospheric pressure till that we can reduce. The dismantle the module, the breaker module, dismantle this, dismantle the breaker, repair and replacement we do in the breaker, and then again assemble the breaker and assemble the module, and then we do the gassing, we do the gas filling or gas handling process, gassing process, and then operations of many equipment according to the interlocks and service conditions we start doing. So this is a kind of the MRE procedure. Am I clear with the MRE procedures with the GIS enclosure compartment? Why we do the compartment? Why we divide the enclosure into small compartments? Am I clear with this?
Yes, sir.
Yeah.
Yeah. Just one question. Does all the compartment have separate gas density monitors?
Yes.
Okay.
Yeah.
Okay.
Also, Mr. Raghu, one more point. Before gassing, there is one important procedure for vacuuming.
Yes. Yeah, vacuuming, right?
Okay.
Yeah.
Thank you.
We have few manufacturer as well with me, the manufacturer engineer. So if they have any opinion, they can also share with me. Amal, would you like to add few point in that? Any?
Sir, we normally provide the service continuity part and MERE.
Mhm.
And what you said is, I mean, to the point. So there is not much to say. But yes, there is a procedure. What other people are also added. So the basic procedure you have said, and there are some more procedures. Like first we will do the gas. We'll take out. We'll do the vacuum. Then there will be a different sort of cleanings and everything will process will be there. So that is a different, I mean, sub parts of what you have said. So whatever you have said is to the point correct in terms of concept.
Yeah. If anything you want to add here, Amal? So
Yeah.
yeah. I will make the list here as well. Your opinion, if you want to tell.
Sir, regarding the maintenance part, we have actually already covered, so not
Okay.
much to add over there.
Okay. So whatever the required that we have covered right now.
Yes. Yes.
Yeah. So this is the responsibility of the manufacturer that they need to provide, right, Amal? Am I correct here?
Yes. This is our responsibility. Correct.
This is
As a
the
JS manufacturer, we need to ensure that we should give MERE proper document, and we also require to comply to the service continuity. Both are same only, but properly documentation and requirement has to be followed.
okay. Okay, thanks. I'm taking the confirmation from you as well because few engineers when they will do their project, so they know that which document required and from where they will get that kind of the document.
Yes.
Okay, yeah, thanks, Amal. So now
Yes.
coming to the gas, about the gas. So during the transportation from the factory to the substation site, the GIS enclosure module is normally filled with the nitrogen gas. This we take nitrogen gas right now, Amol?
Yes. It is correct.
The nitrogen gas, and we take the
Okay.
nitrogen gas to avoid any kind of the moisture in the enclosure. And same, then we do the degassings, vacuum, cleaning, all we do at the site. And then after the cleaning, we refill with the SF6 gas during the installations and commissioning of the GIS enclosure. SF6 gas is superior insulating medium because its dielectric strength is 5 times higher than air. For this reason, it is used in GIS substations. And the gas pressure, the SF6 gas pressure range from 2.5 to 4.5 bar for 33 kilovoltage or 36 kilovoltage. And it may go higher when the voltage level is increasing. It may go up to 7 bar or 8 bar as well. So once the voltage increase, the gas pressure also increase. In EHV substations, in EHV circuit breaker, the SF6 gas pressure is in the range of 7 to 8 bars. And for the rest of the model, it is in the range of 6 to 7 bar. However, depending on product design requirement, it may vary from manufacturer to manufacturer. So ideally, when we do the project, this is a responsibility of the manufacturer to provide us the gas pressure requirement on each modules. And the gas that we are filling in the sub-6 GIS should be in accordance with the IEC 60376 standards. Now, since we have discussed that each module we are taking that would be connected with help of the flange, so there is a probability of the SF6 gas leakage during the operation of the GIS. So as the enclosure are divided into separate gas compartment and connected to each other by flanged joints and contain gasket as well. So due to these flange connections, there is a chance for gas leakage during the service life, during the operation of the GIS, which can pass into the outside environment, and gas pressure may reduce inside the GIS module. And the equipment's arc interruption capability depend on the gas pressure. So if the gas pressure reduce, the equipment arc interruption capability will also reduce. So each GIS manufacturer needs to provide the gas SLD and need to provide the gas pressure of each module. The GIS manufacturer must also provide an online gas density pressure monitor with the SF6 gas pressure with each module. The breaker module gas pressure is higher than that of other equipment models because breaker is doing online uh, arc interruption of the current. So breaker gas pressure we take little bit higher compared to other equipment models. The guaranteed maximum leakage should be less than 0.5 percentage per year. So this guarantee we take from the GIS manufacturer. They need to confirm that the maximum gas leakage will not go more than 0.5 percentage for any individual gas compartment and for the whole equipment as well. This is as per the Indian practice I'm telling, but few countries they ask for the 0.25 percentage per year guarantee from the manufacturer. Like if you go to the UK, National Grid, they ask for the 0.25 percentage per year gas leakage from the GS manufacturer. But in India and the maximum Asian country, we go with the 0.5 percentage per year. So the gas should not leak beyond this. Now, so the gas manufacturer and need to furnish the table for the gas. So snapshot from a project specifications for the gas pressure requirement, and for a different project gas manufacturer gas assembly for the gas pressure requirement. So here I have taken one different project, their technical specifications for the gas pressure, substance gas pressure. So like breaker filling pressure 6.3 bar, first stage allow 5.8, drip on the 5.5 bar, and then for others compartment and for the bus barrier. So this is required by the client, and here the GIS manufacturer or GIS supplier have to provide the gas SLD and have to provide the gas table as well, gas pressure table as well. So I took one snapshot for the gas pressure table as well. This and this not matching because this is a different specification and this is a different SLD drawing. Due to that reason which is not matching, so I'm just taking the reference to tell that this SLD and the gas pressure need to furnish by the GIS supplier. So the breaker compartment 0.7, this unit is MP megapixel and this unit is in bar. So other compartment 0.56, gas to air basins is 0.36, design pressure for breaker compartment this much. So rated gas pressure and design pressure this much, other compartment this much, this pressure this much. So this kind of the tables need to provide by the GIS supplier for the gas SLD. So now one question is like, can I keep my GIS bay energized even if the subsurface pressure pressure in a gas compartment is at ambient level, say 1 bar? Could I keep GIS be energized? So answer is no. All GIS gas compartment must have at least minimum functional density. If the density goes below the minimum functional density, the gas compartment must be switched off immediately, what is recommended by the operations in the GIS. Now, how we fill the gas into the GIS modules? So for that, we take the gas filling equipment, which is called as DELO. So a gas filling point. So first of all, the gas filling point connection shall be provided for each gas compartment at a positions which shall be accessible from the ground level, or that should be accessible from the platform or from the temporary platform, or as agreed with the company. So a gas filling point first we have to provide, or the GS manufacturer have to provide, the first requirement. Second, the filling point shall be compatible with the DELO type DN20 of self-sealing couplings to match the company gas handling equipment, and shall seal automatically when the coupling is removed. If the compartment's filling point are not DELO type DN20, which is the filling point type we are taking, the supplier shall provide compatible conversion adapter valve to allow gas handling equipment with DN20 to be directly connected to the gas filling point. It shall be possible to fit a locking device to the filling point to prevent unauthorized access to the filling point as well. So this is like how we do the gas filling in the GIS enclosures. So now, after discussing about the enclosures compartment, we have one more concept about the phase segregations. The phase segregations are phase division of the GIS. We are discussing about the GIS constructions. So due to that reason, we are taking all this point. Phase segregation. So the concept or the general practice is that for the GIS enclosure for a three-phase electrical system has two options for the phase segregations, depending upon, and this will depend on the customer or project preference, the phase segregations. So depending upon project reference, if any, depending upon the cost considerations, and more importantly, depending on three-phase short circuit rating value. All three-phase conductors could be in a common metal housing or metal enclosure. This is option number one. You can see here RYB phase. RYB phase. Basically, we take we are taking RYB phase here. Could be in common metal enclosure, and it is placed in common metal enclosure. In a common metal enclosure. Or each phase conductor could be in separate metal enclosure or single phase enclosure. If you see this option here, so R here, Y here, and B here. So for each phase, we are taking a separate module. So we have two type of the enclosure: single phase enclosure. This is the single phase enclosure design of the GIS, and three phase enclosure design. So this is the example of a three phase enclosure design. Adopting a three-phase enclosure design up to 145 kV system voltage is economical, cost cheaper, where all three-phase conductors are combined into one enclosure only. So this is the general practice that we follow, that all up to 132 kV voltage level, taking the 66 kV, 110 kV, 132 kV, all equipment, all phases coming inside a common GIS enclosure, combined type. Second, when the voltage level go beyond the 132 kV, so for 220 kilovoltage and above, we take a single phase enclosure. Means for our phase, a separate enclosure will come. A separate enclosure will come. For the Y phase, again a separate enclosure will come. For the B phase, again a separate enclosure will come. So it is economicals, but when the voltage level is increasing, then voltage level is increasing, the size of three-phase enclosure become bulky. So in transportations, erection, installations, it could be difficult. And when the voltage level increasing, the short circuit ratings, short circuit pressure, the arc which will developed by the short circuit current, this also increases. So in that voltage above 145 kV, we generally take single phase enclosure design of this GIS. So a single phase enclosure design is preferred instead of a three-phase enclosure design. Personally, like here we are dividing based on the voltage level, but the electrical function will not change whether we are going with three-phase or single phase. So here we go with the single phase enclosure. Single phase enclosure. Yeah, anything, Amol, that you want to add here, or anything as per your opinion? Is that fine?
Sir, normally single phase, most of the cases single phase is only used. Three phase nowadays used mainly for residential sort of data centers and related part, for more compact design and civil related part.
For 132 kV, again, means if there is no data center, that any utility project you are taking, so in that case also you propose single phase design for this much voltage.
Normally utilities go for single phase only. Three
Up to
phase,
this, for this voltage level as well.
yes.
Ah,
But we have both the designs, even not even 132 kV, 220 also, all the OEMs in fact. So that is depend on the customer requirement we propose.
okay, and the cost consideration as well, right?
Of course, yes.
Cost consideration. So what is the general practice for the general proposal? How you propose this? Means in generally how you propose as per the regular practice?
We propose based on the three phase. Normally we propose for 132 kV or 220 kV, and 400 kV normally single phase.
Okay, so you are telling that for 132 till 132 kV, and you are adding also 220 kV, right?
220 kV, yes.
So here you are trying that you in first attempt you propose the three phase enclosure, right?
Yes, right. Because
And
normally 132 kV or 220 mainly goes to the data centers or that sort of residential things where they require compact design. So
compact
this
design.
help them.
Okay, and for 400 kV you propose the single phase, right?
Single phase. Yeah, in any case, three phase don't have, anyone don't have in 400 kV and 765 kV.
This three phase is a full GIS or hybrid?
No, full GIS.
Full GIS, sir. Full GIS.
Are you working with ABB?
No. Yosan.
Okay, sorry.
They also have, I mean,
No, they
different,
don't have
different.
220 in the India, the full GIS. They are the
Correct. They don't have GIS currently.
Yeah. Okay. Yeah. Thanks. I'm just taking your confirmations because as a manufacturer, you have some like point that you can add with us.
Yes.
Yeah. So now, so here we discuss about the type of the enclosure: single phase enclosure design or three phase enclosure design. Now about the partitions, how we do the partitions, compartmentalization of the GIS. As we have discussed earlier that we do the uh, different partitions with help of the gas barrier insulators. So what is the general practice about that partitions? Again, it will depend on the customer or client specifications, but we are discussing one general practice about that. So as we know that GIS enclosure is subdivided into individual gas-proof compartment or module with help of the gas type insulators. So in this diagram, if you see the PA, this black color PA, this black color PA is indicating the gas type partitions or gas barrier insulators. Here just 1 second. Just 1 second. If I'm telling the gas barrel insulators, so I'm telling this kind of the insulators. So they allow to pass the conductors, but they do not allow to pass the gas. So this kind of the barrel insulators. And this is the support insulator. So they allow to pass the gas here. This is support insulator. So I'm talking about this barrel insulators, which do not allow to pass the gas. So back to the discussions. So this PA is the gas barrel insulators. The common bus bar. So this is point number one, that we are dividing into different individual compartment. Second point, the common bus bar. The bus bar is laid are installed longitudinally in the GIS hall to connect the incoming and outgoing base to the bus bar. So as we can see here, this is a example of the GIS hall. So here we are installing the common bus bars so that all the incoming and outgoing bay can easily connect with this bus bar. The bus bar conductors will be part of each bay. Now here we are discussing about the compartmentalization practice, how we do the division of each enclosure. What is the concept for the division of the compartmentalization of the GIS enclosure. So the bus bar conductor will be part of each bay module, or each bay bus bar isolator. Just give me 1 second. I wanted to tell where these discussions will be related. So if you see this SLD, just 1 second, let me take a project SLD as well. So where this discussion that I'm doing, where that discussions would be interlinked. So if you see this example of the drawing, this is a gas SLD which is submitted by the GIS manufacturer. So as a design engineer, we have to review this drawing and we have to approve this drawing. So in this drawing, the GIS manufacturer is submitting that how many gas density are the location of the gas density monitors plus the compartmentalization. If you see here, one insulator here, one insulator here, one insulator here, one insulator here. And so this is a common, here we have the common bus bar. So now in the common bus bar, we have taken the bus disconnectors here. And then we are putting the insulator here. It means the bus bar and bus disconnector is common. So in order to review this gas SLD, which as a design engineer, we have to review this SLD. I'm discussing about this concept, about the partition concept, The bus bar conductors will be part of each bay module or each bay bus isolator. Just give me 1 second. So the bus bar conductors will be part of each bay module or each bay bus isolator, which means on each bay, the gas tight insulators we have to provide, or the GIS manufacturer have to provide, and the bus bar common module. Partitioning the bus bar at each bay level allow precision isolation of the bus bar compartment. So now what I'm telling here, that whatever the bus bar, we have the RYB phase bus, so we will have 3 bus bars. So whatever the bus bar we are taking, that would not be common, just a straight bus bar. This bus bar we have to take, which is coming inside the GIS enclosure, and this bus bar we have to divide at each bay level. At each bay level. So here we have the bay 1, here we have the bay 2, here we have the bay 3, or feeder 3, feeder 4. So this bus bar at each bay level, each feeder level, we have to divide into separate gas proof compartment. So partitioning the bus bar at each bay level allow precision isolation of the bus bar compartment for extension and avoid damage to adjacent bay in the event of a fault. Due to that reason, we are dividing the bus bar at each bay level. So the left side drawing, here we have the drawing indicating the gas tight partition insulator locations. Gas tight partitions shall be used to separate the compartment of GIS in accordance with clause 5104 of IEC 6227-203 in accordance to guarantee the service continuity of the healthy part of the GIS. For voltage up to 220 kilovoltage, each bus bar compartment may include one bus bar disconnectors and earthing switch. So if you see here, this is a 220 kV SLD. So bus bar here, this bus bar is covering the bus bar isolators and earthing switch, and then after that we are the manufacturer is putting the insulator over here. For rated voltage above 220 kilovoltage, the bus bar and the bus bar disconnectors shall be positioned in separate gas compartment. For 400 kV, this would be applicable. The GIS supplier shall provide a gas SLD showing the gas compartment within the each bay. Let us see this example. So I think this already we have taken. Now coming to this. So this is a gas compartment example. So here we have common bus bar, and now this is our bay 1, filter 1, whatever you can say. So from here to here, this insulators we have to place, the barrier insulators. This is one portion of the bus bar. So from the bus bar, taking the conductors, connecting the disconnectors and earthing switch. Here we are taking the 3 position type 3 PDS type disconnectors, and then here again one insulator here, the barrier insulators, and then disconnectors. Since we have used the earthing switch over here, that is why here it is not required. And then common conductors going to the breaker CT. So from here till here, in this particular case, CT also combined under the breaker module, and then insulators, high speed earthing switch, and then it is going outside for the terminations to the underground cables. So this is the response till here, responsibility of the GIS supplier, and the cables is the responsibility of the EPC contractor. So this is how we do the bus bar division with the bay. Let us see few other practice or partition practice. So in few company, if you company follow the below practice, separate gas compartments shall be provided for the following equipment and devices. So I have taken extract from a technical specifications. So bus bar A, for rated voltage up to 245 kV, each bus bar A compartment may include one bus bar disconnectors and earthing switch, provided service continuity criteria are met, as we discussed before the service continuity criteria. For rated voltage 300 kilovoltage and 420 kilovoltage, the bus bar and bus bar disconnector shall be positioned in separate gas compartment. This is a when the voltage level changing, so this compartment class is changing. Bus bar B, for rated voltage up to 245 kV, each bus bar compartment may include one bus bar disconnectors, earthing switch, provide service continuity criteria met, same as we have taken for the bus bar A. Rated voltage bus bar and bus bar disconnectors, again same as the point number 2. Breaker, this compartment may include the current transformer sometimes, otherwise we take breaker as separate compartment, VT separate compartment, arrestor separate compartment, cable connection separate compartment, and then we take separately the bus duct. So this is a study for the 420 kilovoltage substations and gas compartmentalizations here we are doing. So if you see here, so we are talking about this bay. So here we have bus bar A, bus bar B. Now if you see from here to here, we have one bus bar compartment, and from here to here we are taking one compartment. Just here, disconnectors coming in separate compartment, earth switch coming in separate compartment. Seat breaker CT, it is like combined here. This disconnectors, sorry, this earthing switch in separate compartment. Disconnectors, so from here to here, one compartment for the disconnectors with two earthing switch, and then the insulator here, and then we have the bus duct. So this compartment, so based on the technical specifications or partition practice, we have to review the gas compartment or gas SLD of the GIS manufacturer. Am I clear so far? Amon, anything that you would like to add here about the partitions? Particularly
No, sir, it is covered. It is covered. All important points covered.
the 420 kV also, Hussein provide this kind of the facility, right?
Yes, actually, every OEM has their own design.
Yeah, yeah.
So that way it is little different. So for us it is almost same, but I think Siemens do not provide so many. So they have different design. ABB has comparatively same. G has little more different.
Okay. Okay. Yeah, so it varies manufacturer to manufacturer.
Yes.
Yeah.
Sir, in this one, Raghav sir,
Yeah.
in this one, high speed earth switch is mandatory for 220 kV.
I will come on high speed earthing switch. Okay. You do not go beyond my discussion. I will come on the high speed earthing switch. Yes, it is mandatory if you are on the transmission line bay in that case. Okay. Visa, who asked me?
Raghav sir. Raghav sir.
Yeah, yeah.
Sir, in this compartment for breaker and CT and place in same compartment because it have different pressure, yes?
Yeah, in this, yes. Yeah, in this example, like how we do in your case, how you do.
Most of the cases normally ES has been placed along with the circuit breaker. CTs are different. If it is because normally that is depend on the customer specification, but most of the cases everyone requests that CT should be in separate compartment, and breaker and DS can be in one. So that's how it is there.
Breaker and
DS disconnector.
so you are taking disconnectors and breaker in one?
Yes, in some of the cases they require that sort of things. Otherwise, I mean, there's actually we also have 2-3 different model, but normally CT is not been placed in the same compartment.
Yeah, breaker. So breaker separate, CT separate, and
Yes.
disconnectors also separate.
Yes,
Okay, so you also have one model in that the disconnectors and breaker.
disconnector also with breaker. So that is a specific requirement.
Specific requirement, but not the regular requirement, right?
No, no,
So
no.
as per the regular practice, disconnector separate, breaker separate, CT separate.
CT separate. Yes.
Yeah. Yes, I think Siju, your question is answered. In this,
Yeah, it's clear.
in this particular, they are taking both in same, but usually we take breakers separate and CT separate. And as we discussed, it depends on the client technical specifications, which kind of practice they want to follow.
Okay, sir.
Just one point, sir, because normally CT is multi-core and other things will be there. If there is a that is basically for your metering purpose and which is been for utility, definitely they don't allow this practice. And
Yes.
second part is if something happens with the CT, complete breaker need to be, I mean,
Yes.
will get shut down. So that is the reason normally they don't prefer
Yeah.
to go this design.
This design, correct? Yes. So breaker separate and CT separate.
Yes.
Yeah, that's the safer side. Okay, so below is the overall partition for the GIS models and equipment with the help of the gas light barrier. So let us same we have taken again C2, so you can note down again. Bus bar with disconnector one module, okay, right? Breaker module is one module. This compartment may include CT, but generally we do not prefer to include the CT into the breaker. So breaker is separate module. Line disconnectors module separate, CT separate module, BT separate modules. Gas insulated bus duct separate modules are between GIS and XLP cable, and gas insulated bus section between the GIS and the transformer is also separate partitions we take. So each module or partitions will have a plug-in or easily removable connections to allow for easy replacement if any module with the minimum disturbance to the remaining equipment module. So means they have plug-in type or removable connections so that easily the controller could be connected. Whereas for the medium voltage, high voltage GIS means 33 kV GIS is provided with many function integrated into each module like isolated earthing switch CTCP means this is for the 3.3 kV, 6.6 kV, 11 kilovoltage, 33 kilovoltage, a small voltage GIS like a small voltage means 33 kV GIS is provided with many functions means just in order to save the cost, many equipment we club into models. The benefit of this is compact and low cost, but the disadvantage is more difficult in maintenance and outage time is also higher. So AHV GIS is generally provided with single function within each module, means isolators only, breakers only, CT only. The benefit of enhancing availability and so easier maintenance, but the disadvantage is of higher cost and large GIS base size as well. This is the partition practices. So to indicate the GIS partitions, the location of gas barrier insulator is to be clearly visible or marked outside the enclosure by a band of different color. So what we discussed, this is the internal partitions. So how this internal partitions will like appear outside. So for that we take this kind of the marking, the orange color marking. So whenever you visit to the substations and you see this marking, orange color marking, it means you understood that this is the barrier insulators and this is used here for the partition purpose. So to indicate the partitions, to indicate the GIS partition outside, the location of gas barrier insulator is to be clearly visible or marked by the manufacturer outside the enclosure by a band of different color, which is normally used for safety purpose and to show the partitions outside the substations for O&M engineer as well. The color may be defined by the owner during the procurement of GIS, but is usually in orange color. The modules shall be provided with hooks for handling by EOT crane, and the crane will be provided in the hall. Static filter density switches, filling, evacuations wall, pressure relief device shall be provided in each module for safety reasons. So I hope I'm discussed with the clear with the partitions. The partitions. So what we discussed, let us summarize this. What we discuss about the enclosure material, what we take, enclosure partitions we discuss about the MRE procedure for the enclosure. We discuss about the gas pressure and gas leakage, why the leakage happened in the gas, and then we discuss about the guaranteed leakage by the manufacturer. We discuss about the gas pressure recommended, then we discuss about the gas fillings, and then we discuss about the enclosure phase segregations. This we discuss, and then we discuss about the after the phase segregations. After the phase segregations, we discuss about the enclosure segregations as well. So our enclosure partition as well. So am I clear so far about the partition practices? Right. So let us move about the GIS module fittings, that what fittings we provide for are the manufacturer provide with each modules. So each module or each partitions shall be provided with separate gas monitoring equipment, including necessary piping and valve to allow isolations, evacuations, and gas refill without evacuating any other module. Each module shall have static filters, density switches, safety pressure relief device, The filter shall be the filter that we are using. The filter shall absorb water vapor which may penetrate the enclosure, and byproduct of a subsystem gas. Each gas compartment shall have a temperature compensated gas density switch as well for monitoring and maintenance. And this we do the online monitoring. So let us see about the fittings. So here I have taken a piece of the enclosure. You can see here a piece of the GIS enclosure, and each partitions must be provided with all fittings. So each GIS compartment or each GIS module must have the above set of fittings for the reliable operations and protection of the module against abnormal conditions. So what are the fittings that we take for each piece of the module, each piece of the enclosure? So this is our enclosure. You can see, could you connect here? Let me take the snapshot as well. Yeah, so this is enclosure. Here we have this enclosure. Now we are putting like this. Okay, so here we have the enclosure. Inside the enclosure, conductor will go. So here we have the conductor, the bus bar. Now in this enclosure, you can see this kind of the fittings when you visit the site. You can see this kind of the fittings when you visit the GIS hall. So let us see about those fittings. So those fittings are, first of all, it should have the barrier insulators, which is orange color, visible outside of the enclosure as well. Then support insulators, which is not visible outside because it is supporting the conductors. Support insulators. Again, support insulator, barrier insulators again here, and density monitors, density monitor, cable to the local control cabinet from density monitor, pressure relief device, this much. So you can see this one is the PRD, pressure relief device, absorber. So if any moisture content, it will absorb, and then gas filling, refilling, or evacuating valve as well. So this all, any other fittings that we take apart from this, with the enclosure?
Major are these only. Only if there will be 3-phase, then there will be little different. Or if a length is on the means bus bar is heavier, then we have to make a different setting. Otherwise, these are the basics, sir.
That with each models we have to provide this, right?
Yes, yes.
Yeah. So means this the manufacturer responsibility is to provide this aluminum or copper conductor here, as you can see. So now coming to the fittings one by one, let us discuss about all the fittings and why we are using those fittings in the GIS module. So the first insulators, as you can see, there is two kind of the insulators. So the GIS compartment has two type of the insulators: support insulator and the barrier insulator. Barrier means gas barrier, means gas stopping, not allowed to flow the gas, which is the barrier. Support insulator, these insulators allow the passing of the gas and provide support to conductors only. Is there any recommendations you have that how much should be the gap between two support insulators? Is any kind of specifications available? Anu?
Sir, depend on that. I think some gas, I'm not sure because that need to be discussed with our design. But I think that gas density need to be equally at everywhere. So there is some formula they do it. I'm not sure on that part at this moment.
Okay. So this is calculated by the GIS and design team, right?
Yes,
The
correct.
internal design team. So if possible, if you discuss and let us discuss this as well in the next class. That
Sure.
how they decide number of the barrier insulators, how much it required.
Sure.
Okay, so support insulators. So these insulators allow the passing of the gas and provide support to the conductors only. Conductors only supporting. Then we have the barrier insulators. So these insulators does not allow the passing of the gas. It is due to this reason we are telling as a barrier insulators, and only support the conductors. So only support the conductors here. So this is the support insulators that we are using. So about that we discussed. Now coming to the next, which is the gas tight or gas insulating barrier in more detail. To reduce the damage area and to get maintenance flexibility, the entire GIS enclosure or equipment housing subdivided into several small compartment or modules and divided in the GIS enclosure. This part already we have discussed. So this is already covered. Gas tight barrier. So anyway, this already we have covered. These gas tight barrier insulators are called pressure resistant spaces. Divide the bay into separate gas compartments that are sealed off from each other. Each separate module is connected to other with help of the flange and gasket. So there is a probability of gas leakage. So anyway, this is all we have discussed. So along with the gas barrier insulators, the GIS have support insulator. This all also we have discussed. For the GIS enclosure partition, the client or individual may also have their own standard, so we need to check the tender technical specifications as well. Anyway, this all we have discussed. So the next fittings is the density monitor fittings. So here I have taken the site photo. In that, this density monitor fittings you can see. So this is the density monitor fittings, right? Density monitor fittings. So to continuously monitor the gas pressure or gas density in every gas compartment, means in every closed space between orange mark, there is one number of gas density monitors shall be provided. The density monitor device shall be provided with at least 2 set of alarm level for gas pressure. So low pressure, first stage is low gas pressure alarm for online gas topping up, and second is the tripping of circuit breaker, and for that 2 potential free electrical contact shall be provided with each monitor by the GIS supplier. So here they also furnish one table in that they mention about the like stage 1 alarm and stage 2, and then lockout or the tripping. So rated SFSS gas pressure 0.6 here we are taking for the breaker module. Suppose we are taking. So once this during this service of the GIS module, gas also it may leak because of the flange connections. So when the gas pressure reaching to this level 0.55 bar means 0.5 it is reduced, then the first low level alarm it will go to the operator, and if operator attended those alarm and fill the gas, then it's fine. But if in case they ignore this, and then when the gas pressure again reduced till 0.5, then it will trip the circuit breaker and it will go into lockout stage, and we could not electrically operate the breakers. So this is the gas density here, and then gas density alarm here, and for that we take the 2 potential free electrical contact. Then third fitting is the pressure relief device, PRD fitting. So you can see this kind of the fittings with the modules, this kind of the fittings. So those fittings are representing the PRD, pressure relief device. So in every gas compartment, is again in every closed space between orange mark, one number pressure relief device need to be installed to protect the main gas enclosure under worst operating conditions and protection from damage during the occurrence of abnormal pressure generated by internal arc within the GIS compartment. So due to that reason, in order to protect the enclosures, the pressure relief device need to provide it between each and every gas compartment. The next fittings is the absorber. So each gas compartment is equipped with an absorber to remove the moisture and decomposition of product out of the gas molecule. So below is gas section. So here this kind of how this absorbers looks like. So now next the GIS supplier have to again prepare the gas SLD. In that gas SLD they have to indicate about all the fittings. So here I have taken example of the gas SLD. So again, if you see here, we have the GIS enclosure. Inside we have indicated the red color, which is indicating the conductors. So main bus 1, main bus 2. So from here to here, putting the barrier insulators, and then from here, conductor coming, and it is like covering the bus disconnectors. So from here to here, this is one compartment, right? Till here to here. So in that compartment, this fittings, what we discussed, like gas valve, gas pressure switch, gas tight spacers, rupture disc, RPRD disc, static filter absorbent. So this all fittings need to be provided. So this one here, second here, and third here. So this all fittings the manufacturer need to be provided, and their quantity also they need to furnish that how much fittings required, how much total fittings required. So that also we vary by we review by reviewing the gas SLD. We review those quantity as well. Let us see a few more example about the gas SLD. So here if you see, so main bus 1, main bus 2, and then again 2 main bus per scheme, there is one outgoing feeders. So here if you see the like breaker modules, so in that GD, this gas density devices used. Right. So one for RYB, GD1, like then we have GD2, GD3, GD4. So like that, they will furnish the quantity. The GIS manufacturer will furnish the quantity. So we have to review the quantity, like here total 7 numbers gas density device used with taking the reference of the gas SLD. So these are the fittings. These are the fittings that we takes, and this fittings is indicated into the gas SLD drawing. So let us discuss about the GIS equipment modules or equipments that we take one by one. So should we continue or we should take it tomorrow?
Sir, tomorrow
Tomorrow,
is good, sir.
Yeah, because
Tomorrow,
I don't. Yeah.
Tomorrow, sir.
Yeah. Okay. So because we discuss a lot of theoretical parts, so please have a look, and then if any query we can discuss tomorrow as well. So tomorrow we'll discuss about the equipment modules. So how we do that equipment module compartment, like we discussed that for each equipment we take the separate compartment. So how the separate compartment we take and how that compartment looks into the GIS SLD and how it looks at the site. So I'm taking the site photo and then I'm taking the drawing as well, so that easily we can understand the drawing and easily we can identify the module when we visit to the GIS type substations. Okay, so this all discussed. Let's discuss this all tomorrow. Okay.
So just one point, as you said in the earlier starting that outdoor type mainly AIS, actually GIS is also outdoor
Yeah, yes,
type.
correct.
That is only just want to add.
Yeah, GIS also we take outdoor, yes. Yes, we can take GIS also as outdoor type. Yes, in a few cases we take.
Yes.
It is not the regular practice, but yes, it is possible.
Excuse me, sir. This outdoor GS is a kind of hybrid GS or normal? You can call it as a hybrid GS or normal GS only.
No, normal GIS we are saying. Actually, hybrid and complete GIS both also having outdoor type applications. Hybrid is basically for the outdoor only, and this normal GIS having two functions. One is normal indoor type and outdoor type. This is particularly outdoor type we are referring.
Okay, so is there any major difference between indoor and outdoor?
Yes, mainly, there will be specific cases where only we are using. There will be different type of mechanism. IP will be different. Painting related part will be different. So it will be basically it is used to avoid the civil related part if it is not possible.
Sorry,
Building means building it is not possible to make the building.
you also have the container type GIS, no?
No, I could not get you, sir.
You also have the container pack GIS also, no? the box container with the hybrid module.
Container, yes, container type. It is there, yes.
So
But
that can be
normally
used
that is
for the
goes.
hybrid,
Normally that is required in
hybrid section.
Gulf related part only because of their dust and storms and everything.
Yeah,
They prefer that basically.
dust storm.
So for the containerized container GIS, that is compact GIS. So till which voltage level can use? May I know, just that is I have one doubt actually. Till which GIS we can have that? I mean that
I have
container.
actually I have not heard more than 220 kV. Frankly, if you ask me,
Okay,
132
okay.
and 220 kV only.
Is there? I mean that for the transportation also it is quite difficult, right, to carry that containerized GIS.
Yes, correct. Basically, that has been used in applications like Gulf and maybe related to solar, where it is very
So,
outstation and other things.
as per
Otherwise, I have not seen.
as per my
Okay.
discussion with ABB, they have the modular type also. The phase wise container also and the three phase. Depend on the if you are going with the 220 above, they are the single phase container also. So we have to assemble that one. That's not the issue.
Okay. Okay. So while doing the transportation, they will
Yeah,
transport the
they
A wise,
transport this. Yeah, single phase.
A wise
Yeah,
they will transport, right?
they have the single phase container also with the
Ah,
inlet and outlet thing, and they are uh, combined at the site. That's not the issue.
okay. Thank you, sir. Thank you.
Yeah, thank you, Dinesh. Any other query?
Sir, I have a query, sir. Hello.
Mm-hmm.
Sir, regarding PD monitor, how do we decide the quantity? Is this something connected to the
Yeah,
length of
the
the bay?
manufacturer, yeah, the PD, again, the manufacturer will decide, Santosh.
Okay.
Yes.
Okay.
Yeah,
My second,
along with the fitting, I can also include the PD. This fittings also decided by the GIS supplier.
okay, because they sometimes gives more PDs as per the requirement. So we cannot argument with them why they are taking so much PDs. Because maybe they have a requirement of that. So as per they can give as per their requirement. I think we cannot contradict with the
Generally,
their.
for each models, we take one PD. Generally,
But if we talk about the base, if length is base too much, then PDs needs to be also increased. No? So the
yes,
quantity,
for each, yes, it will
but the
increase.
quantities will be decided by OEM. You cannot
Yeah.
decide by client or something.
Yes.
Okay. My second question was, it is regarding to tolerance. When we connect with the transformer to the GIS with the base, so sometimes GIS will tell when we connect with the flange with the transformer HV bushing of flange. So sometimes they will ask if we have only some minimum tolerance. So like they tell up to 50 mm they can give the tolerance, but sometimes it will not be possible. Such things has to be considered at site. So we have to maintain the tolerance of that so that the connectivity should be proper with the case of bushing and also base. Hello.
Let's discuss tomorrow about the terminations in that tomorrow we
Okay.
take on this.
Okay. Okay.
Sir, can I have a couple of minutes from you, sir?
Yeah.
Sir, I'm planning to get ETAP for my company. So basically, for the oil and gas, what should be the models I purchase? So there are
Okay,
a number of models.
let us discuss one to one,
Oh,
Dinesh, after the
fine, sir.
class. Yeah.
Sir, one more I can talk.
Whatever we have discussed so far, if in that topic, if any query, yes, we can discuss. Otherwise, if
So this it is regarding clearance. OEM is sometimes tell ki there needs to be a clearance between LCC panel and the module. Is this required any clearance between LCC panel and the module?
we'll take up
Some
tomorrow.
electrical clearance is it required? Or it can be we can just place just nearby without any space.
Normally,
did I
there
mention?
are LCC can be also placed along with the GIS also. There are cases where it has been requested by the customer, but normally, see, because of sometime vibrations and related part, it is not been preferred. Unless
Okay.
requirement is there, then only we give LCC along with the GIS. Otherwise, normally it can be just opposite to GIS. You can place
Oh,
like
yeah, yes.
that is the normal practice to ensure that
Mm.
there should be a sufficient electrical and maintenance related distance should be there.
We'll discuss tomorrow, Santosh,
Okay.
about that.
Okay.
And
Okay, sir.
electrical clearance is not too much important there. Only the mechanical passes to be maintained there, because the equipment is inside the modules. It is not exposed. So mainly the mechanical clearances we have to take. Anyway, we'll discuss during the layout. Okay, any other point?
Hello, it is regarding arrangement of the base. We can put RYB in vertical also, sometimes RYB in horizontal way also. But it is in the line way, it is essential to put RYB in vertical way. If two line is each other down. Yeah, so putting in arrangement in RYB in vertical way is essential.
No, I don't think so. Any kind of the like horizontal or vertical, any kind of the orientations, it can be placed. Mechanical stability is achieved, so it could be horizontal or it could be vertical.
It's all depend maintenance point of view.
Yes, yes, yes.
Okay. Thank you. Thank you.
Sir, one point is I think your if you put vertically, then your building height will also go
Yeah,
up.
building
So
height.
that is also we need to see the economical part.
But sometimes what the if two line is in parallel to each other, the maintenance point of view, if you one line should not be interrupt when other line is in under maintenance. Like if
Yes.
you put in vertical manner, then both line in parallel each other, so we can do maintenance without interrupting to the one line. But if you put in horizontal RYB and horizontal one line and second line is below that RYB, then in case of second line, if you want to put in maintenance, we have to anyhow shut down the line too. In that case, we have to in vertical.
Your point is correct, sir. That is only again this is we can't go more than 8 meters normally because of
Okay.
the civil cost will go much higher compared to this. So that is one of the consideration. Otherwise, we can put as per the requirement, vertical or horizontal.
Both is possible. Yes. Okay. Thank you.
Yeah, yeah.
Hello, sir.
And like GIS manufacturer also provide the buffer compartment. So this buffer compartment only to provide the easy access for the maintenance. Sometimes that buffer compartment also used inside the enclosure.
Sir, repeat the VFO, sir, and another approach, sir.
Yeah, come again.
Sir, please repeat the VFPO and another approach, sir. You are telling, but I not understand, sir. VFPO, how to work that?
What you are not getting in the VFTO?
Sir, sir, misunderstanding will be occurs in the VFPO. You keep telling that point, yeah.
You again check the class, and then if doubt still persists, we can discuss again.
No issue, sir. Okay.
Yeah.
I check and I repeat.
We'll check this.
Okay, sir.
Yeah. Okay. So if no any other query, we can wind up today, and tomorrow again we start same time.
Okay, sir.
Yeah. Thank
Okay,
you.
sir.
Thanks all.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir. Good night.